With these inequalities, all right, what's going to be important is that you are able to interpret them either left to right or right to left. It's important that you're able to interpret them back and forth, okay? Now, these symbols that I've got on the TV right now, these are symbols that you should be familiar with. You are probably going to be most comfortable interpreting them from left to right, okay? And that's fine. That's where our comfort level is. But I'm just telling you, hopefully through some practice that we're going to get, we can also interpret from right to left. But that's going to be very important that you're able to interpret these in both directions. This first symbol right here, upon looking at that, what symbol would you interpret that as being? From left to right, if we're interpreting from left to right, this would be greater than. Okay? From left to right. And like I said, typically that's how we read. That's typically how we interpret things and work things, is from left to right. So therefore, what would the next one be? Okay. All right. And I don't know, some of you may have been taught about the alligator or the Pac-Man or whatever, but remember, the alligator mouth opens to the bigger thing, okay? All right? So what would the next one be?
Less than, or greater than or equal to.
Less than or equal to, okay? Less than or equal to. Okay? And again, we're interpreting these, we're kind of defining these as we look at them from left to right. And then obviously, what would the next one be? Okay, great. Greater than or equal to. In that nice sloppy handwriting of Mr. King's. But you know what it means. Okay? And I think it's obvious. I think it's obvious that if that inequality symbol has a line underneath it or half of an equal sign, that's the or equal to part. Okay? And I'm assuming that's fairly obvious, okay? The other thing we need to talk about with these symbols is we are going to be graphing the solutions for these inequalities, okay? Do you guys remember open and closed circle stuff? Open and closed circle stuff, okay? Greater than and less than. Greater than and less than. Here, I'll use a different color. Greater than and less than. We're going to use an open circle, okay? When we graph with these inequalities, greater than and less than, we are going to use an open circle. What does an open circle mean? An open circle means we cannot include that particular value. Okay? Open circle means do not include that particular value. Okay? So, for instance, is 3 greater than 3? It is not. That is not a true statement, okay? 3 is not greater than 3, okay? But 3.1 is greater than 3, okay? 3, you would not be able to include 3 in those solutions, so therefore you would use an open circle. Open circle means do not include that respective value, okay? Well, if greater than and less than require an open circle, what do you think less than or equal to, greater than or equal to will use? A closed circle. Okay? Open circle versus closed circle. Okay? A closed circle means please include the value in your solutions. Okay? Closed circle means include that respective value in your solutions. All right? Because here's the thing with inequalities. You know, we've solved a lot of equations lately. Solving equations, you end up with an answer. You end up with a number or a value, one, that satisfies a mathematical sentence. With inequalities, you are talking about a range of numbers that are going to make a particular statement true. Okay? And we need to be able to show that visually on a graph and also be able to talk about it. Okay? So we're talking about solution sets of numbers. Okay? That's where inequalities are a little bit different. Okay? There's a whole lot more solutions involved. All right, is everybody okay with the symbols and the interpretation here? What we got? Lana?
No, I'll see.
Okay, all right, thumbs up. Awesome. Okay, so let's take a look at this. All right? We've got an inequality here. We're going to graph the solution, but before we graph it, we need to make sure that we can read it appropriately. Okay? Now listen carefully. When you interpret an inequality, I would recommend that you read it from the variable to the number. Read it from the variable to the number. The variable is on the left here. And again, we're going to be more comfortable reading these from left to right, just like it looks, okay? But I would always encourage you to read an inequality from the variable to the number, okay? So when we read this, we're going to look at x, and we're going to reference that x as values. X represents values. It can represent a lot of values. But this inequality is describing values that are less than 4. And that's how I'd like for you to read it. This inequality is describing values that are less than 4. There's a lot of numbers that are less than 4, right? Matter of fact, there's an infinite amount of numbers that are less than 4. So you're talking about a solution set that is very large, okay? It's not just one number. It's not just two numbers. It's a bunch, okay? Now, if we are going to graph this, we're going to get a number line. All we need on that number line is a 0 and the number that's involved. Okay? Put the 0 on there just so we know where the positive and negative side is. Okay? We're just going to put the 4 on there. Okay? We want to graphically or visually represent all numbers or all values that are less than 4. Well, because it's a less than symbol, would that require an open or a closed circle?
Open.
It would be an open circle. We're going to put an open circle around 4. Because we cannot include 4. 4 is not going to be less than 4. That is not true. Therefore, you cannot include 4, hence the open circle. Okay? Which direction would you need to travel on this number line to find values that are less than 4? To the left. Arrow to the left, indicating that you're going to go that way forever. Every number from 4, but not including 4, back to the left is going to be a solution for this inequality. It would make a true statement. And that solution set is now graphed. Okay? We okay with this? Everybody good? Does this jog your memory a little bit? Something you should have done before?
Yeah.
Okay. All right. Another one. Let's take a look at this one. And again, when you read inequalities, I would recommend that you read them from the variable to the number. Okay? Most of the time, you will be able to read them from left to right. Okay? I think that is ideal. That's where our comfort is in interpreting these things. So right here, we're going to interpret this as values that are greater than or equal to -3. Values that are greater than or equal to -3. Number line, 0, -3. Open or close circle with this one? Close circle. It's an or equal to. That means that you will be able to include -3 in the solution set, because -3 is equal to -3, or equal to, greater than or equal to. -3 is equal to -3. That would be true, therefore a closed circle. Which direction would you travel on a number line to find values greater than or equal to -3? You would go to the right. And that solution set has now been graphically represented. Okay? All right, so far so good? Fabulous. Okay? This one makes this pretty easy. All we got to do is put 0 on the number line. What is this inequality saying? Somebody tell me what this one's saying.
It would be closed. It'd be open, and then going to the.
So when we see the variable, we're going to refer to that as values. Values that are greater than,
Or equal to.
Greater than.
greater than 0. Values greater than 0. Okay? Yes, I know it's an x. X is greater than 0. But what does x represent? It represents all numbers that are greater than 0. Values greater than 0. Open or close circle? Open. And direction. Values greater than 0. But you cannot include 0. Hence the open circle. Okay? Open circle means do not include. Okay? All right, let's take a look at this one. What kind of values is this inequality describing? Say again? Values less than 5. You are exactly right. Now, here's one right here, guys, that is, you're going to need to be able to read it from right to left. Okay? The variable is on the right-hand side here. Most students will read this, 5 is greater than x. Okay, that's true. But what is this saying about the solution set? These are values that are less than 5. Okay? We need to be able to read this one from right to left. So on the number line, 0 and 5, open or closed?
Open.
Open. Which direction?
Right.
Left.
Where are values less than 5? To the left. Now, let me caution you about something, okay? Listen carefully. Most of the time, the arrow does point the same direction as the inequality. But I'm telling you right now, you need to understand what the inequality is telling you so you understand which way to put the arrow. Because right here, that inequality is pointing to the right. There's going to be a tendency to want to look for or put the arrow to the right. But if we understand the inequality and knowing what it says, values less than 5, we need that arrow back to the left. Okay, so be careful with that. All right? Be careful, because the majority of the time it does match. Okay? So be careful of this situation. When you see it, we need to be able to read it back the other way. Values less than 5 here. Okay? Any questions about that? Okay. All right. Whoops. Whoop. All right, let's do this real quick. What if I did this? Let's say that you were given a graph that looked like that. This time you have the graph first. We don't have the inequality. And let's say that we were asking you to write the inequality based on what you see out of the graph. It's a 6.
Okay.
There you go. There you go. Good question. So, what is this graph describing? Values that are what?
Less than or equal to 6.
Why is it or equal to? Because a closed circle. Values less than or equal to? 6. Okay? So again, based on the information that we see on the graph, we need to be able to write an inequality that matches what we see. Okay? What if we have that? What is that graph describing? Values that are what?
Greater than 2x or less than.
Values greater than. We've got an arrow to the right, so it's a greater than direction. And it's greater than -2. It's greater than because it's an open circle. We cannot include -2. Okay? So we need to be able to see an inequality and graph a solution, but we also need to be able to see the graph and interpret and write the inequality that matches the graph. Okay? Can we do that? Can you do it? Going to use the same process that we use to solve equations. Okay? The big thing with inequalities is the question you see on the TV. When do you flip the inequality? Does anybody remember?
Oh, whenever if it's the number before the.
When do you flip the inequality? How do we know to flip the inequality? Well, here it is. If you multiply or divide by a negative. If you multiply or divide by a negative at any time, okay? That's the one thing that you need to be able to kind of keep up with throughout the inequality solving process. If we multiply or divide by a negative at any point, we want to flip the inequality. Okay? All right, so let's look at one here. 3x plus 2 is less than -4, okay? Instead of an equal sign, we are going to see an inequality symbol now, okay? That inequality symbol still divides the problem into a left side and right side. So just because we don't have an equal sign doesn't mean we need to abandon all that. So our equation solving process is still in place here. The inequality is what's going to divide the problem into left and right, and we're going to approach it the same. What would be the first thing you would probably need to get rid of here? Isolate the variable term. Let's get rid of that 2. Let's get rid of positive 2 by subtracting 2. 2 minus 2 goes away. Negative 4 minus 2 is equal to negative 6. Keep that inequality the same for now, okay? What's going to be the solving step? By?
3.
Positive or negative? Positive 3. Because we are dividing with a positive means that the inequality symbol is going to stay the same. Okay? Now, again, going to be very important that when solving inequalities, it is important that that entire thing is listed as the answer. We are talking about a solution set of numbers. We're talking about all numbers that are less than negative 2 will work for this inequality. Okay? So, unlike equations where you guys are just able to put a number, okay, you're going to need this entire thing. You're going to need to put x is less than negative 2. Okay? Because we are describing an entire solution set. If we were graphing this, would this require an open or closed circle? Open, and it would point which direction? It would go to the left. Okay? So I'm going to try to keep emphasizing the graphing portion of that. Thank you, sir. Okay? Everybody okay with this?
Wait, hold on.
Any questions?
No, sir.
Stay with the equation solving thought process, okay? But we're going to have to try to keep in mind at any time if I multiply or divide with a negative, that inequality is going to flip. And that is going to change the solution set greatly. Okay? All right, let's look at another one here. X divided by 6 plus 2 is less than negative 1. What are we getting rid of first? What was it? Isolate the x over 6. So how will we do that? Fantastic. Subtract 2 from both sides. Subtract 2 from both sides. That's going to leave us with x over 6 is less than negative 3. Watch those integer rules. How do we solve?
Don't you divide?
You don't divide yet. You gotta keep breaking it down.
Good morning, Tate students and staff. We are going to conduct our month.
All right, so here we are. We got where x over 6 is less than negative 3. What's going to be the solving step? Multiply by 6. And we're multiplying by positive 6. Therefore, the inequality will stay the same. Okay? Although that the number coming out on the other end is negative, how did we get there? We multiplied with a positive number. Therefore, again, the inequality stays the same. Again, something we've got to kind of keep in mind. If we were going to graph this, said if, open or closed? Open, which direction? Less than would be to the left. Okay? If we were going to graph that. Okay? All right? Any questions there? Are we okay? Okay. What's the variable term in this one?
So what about?
What's the variable term? Negative 7x. Now notice what's setting in front of this x here, okay? In front of that x is a negative 7. We are probably going to have to divide eventually with that negative 7, okay? If these are things that you can recognize ahead of time and that you're aware of, you can anticipate that sign to be flipped, okay? Now, what's the first thing we probably need to get rid of here?
8.
How?
Subtraction.
Beautiful. Let's subtract 8 from both sides. Let's subtract 8 from both sides.
Then you divide.
Divide by what?
Positive 7.
Divide by exactly what you see there.
Yeah.
Because a negative divided by a negative is going to be a positive. So let's divide by negative 7. We are dividing with a negative value here. Guys, this inequality needs to flip. That solution set is now going to read values that are greater than or equal to positive 1. Okay? So again, it's going to be imperative, it's going to be important that we are aware whether or not we multiply or divide with a negative at any time. If we do that, that inequality needs to flip. Okay? If we were going to graph this, open or closed? Closed. Which direction? To the right. If we were going to graph it. Okay? But like I said, the equation solving process is in place here. You just need to be able to keep up with whether or not you multiply or divide with that negative. Okay? All right. Questions?
Anything with a 900 is closed.
Any questions?
No, sir.
All of them crazy.
Nope.
Okay. Well, I must have done a fantastic job teaching. You guys are going to do an awesome job getting it done.